Number 10. Angle J is congruent to angle H. Angle JGK is congruent to angle HKG. Angle KGH is congruent to angle GKJ. Segment GJ is congruent to segment KH. Segment KJK is congruent to segment HG. Segment GK is congruent to GK. Therefore, triangle GJK is congruent to triangle KHG. Number 12. Angle A is congruent to angle F. Angle B is congruent to angle J. Angle C is congruent to angle I. Angle D is congruent to angle H. Angle E is congruent to angle G. Segment AB is congruent to segment and FJ. Segment BC is congruent to segment JI. Excuse me. Segment CD is congruent to segment IH. Segment DE is congruent to segment HG. Segment AE is congruent to segment FG. Therefore, polygon ABCDE is congruent to polygon FJIHG. Number 14 is 42. Number 16 is 10. 18, Y is 40, and X is 35. 22 is a proof, so we can certainly look at it in a minute, assuming we need to.
What about 20?
20, X is 4 and Y is 1. 24 is also a proof. What did we go through? 24? Yeah. 24 is also a proof. We can certainly look at it if we need to.
I was confused on 22.
On 22.
Because it like gave you the answers.
Yeah, it gives you the steps. You have to write the givens. I mean, not the givens, the justifications. It gives you the statements. You have to write the justifications.
Can we do 20?
Yeah, we can do 20.
Wait, you usually don't come on Thursdays or Tuesdays?
Somebody stole my black marker again.
Oh, you're wearing the hat and support Roswell.
Oh, no, I just got it at the Alien Festival.
Supporting Roswell. What is there to support in Roswell?
They're like
The aliens.
they're having like really horrible flooding and a couple of people died.
In Roswell?
Roswell? Like,
It's the
Podunk
aliens'
Desert
dog.
in Roswell?
Flooding.
So,
France, Italy.
in a way, that makes sense. I mean, the flood, I don't know where the flooding is coming from. That's intriguing. But if Roswell gets like hardly any rain, I bet it floods crazy and isn't remotely prepared for it. That's kind of like what Lubbock used to be before they put in all the pipes and stuff. But yeah, so that's wild. I did not know that.
And South France and Italy, they're also having flooding like entire.
Well, that's like in Europe. Who cares?
There's like water everywhere, but there's like so much of the world right now.
Well, it is that season.
There's a couple of hurricanes. Something
Yeah.
like that, I don't know.
And there's 2 more forming.
Merry Christ. So are they hurricanes or are they tropical storms?
Well, there's 1 tropical storm and 2 hurricanes.
Well, the thing about tropical storms is sometimes they turn into hurricanes.
Absolutely. But
So we have the Dean and Oscar are the 2 hurricanes.
I'm not understanding creative with the names. Jesus.
Creative with the names that you said.
Yes. Oh my God. See, how boring would it be to be like, oh yeah, my home was destroyed by Hurricane Frank.
Or Hurricane John.
You know,
Like,
like that's a little lame.
Bill.
Of course they just had to name it Hurricane Helene. It could have been anything else.
Come
well,
on, there's like a whole difference in vowel. Come
did
on.
you know that 58 years ago, another Hurricane Helene hit North Carolina from the other side?
Yes.
Yeah, 'tis the season, huh?
Why is my birthday and everything just named after like destruction?
Okay, so we're supposed to find X and Y. So what should we do? This is a funny problem.
15x minus 8y equals 52, but you still can't solve it, right?
Yes, you
It's
have
true.
two variables in the equation, so then you put 6x plus 14y equals 38.
That's true. You do put that. Now, so what you just said was 6x plus 14y equals 38. Now, where did you get the 38? You're not wrong, but where'd you get it?
90 minus 52.
Yeah. So this has got to be 38 because all the angles in this triangle add up to 180. So 180 minus 90 minus 52 is 38, right? So we've got another equation. If you have two variables, you have to have two equations, and then we solve a system, right? So we end up with 6x plus 14. What's happening? Plus 14y equals 38. Now we can solve that system. How do y'all want to do it?
The regular way.
There's not a regular way. Next year you're going to realize, next year you're going to learn that there's 5 ways at least. I'd use elimination if it was me. You could. You're going to end up with weird fractions, but you.
Okay, let's do
And what you might even do, you might even note, I'll kind of throw this in for free, is you might even divide this one by 2 and end up with smaller numbers, right? So you could end up with 3x plus 7y equals 15 plus 4 is 19.
So then we would have to multiply that by times 5 or negative 5.
Yep. Yeah, so just like Reese said, now if we reduce that one, we can just multiply this top one by negative 5, right?
Where do you get that?
Because we want the x's to be opposites. Because we went back to algebra 1 and are doing elimination.
Right, but why are we doing -5?
Because negative 5 times 3 is what? Negative 5 times 3 is what? There you go.
Oh, okay, so we're making it.
Yep. And then minus 35y equals negative 50 plus 4, 90? Is that right? No, 95? Somebody punch it on the calculator. I already did it in my head. Do it, sanity check for us here. 95. Negative 95. And then we eliminate, right? So those cancel. And then we've got negative 43y equals negative 43. I hate that sound. Is there a question, like, is there a real question or you're just catching up? That's why I hate that sound, because it can mean like 500 different things.
So it's just -42y equals -.
Yeah, but do you understand where it came from?
Yes.
Okay, good. So just catching up then. All right. So then we divide the negative 43 off. And y equals 1. Then what would we do?
Plug in y
Yeah, where?
with a 6x plus 14.
Up in here? Sure, that's fine. Or here, or here. Any of those will work. All right? Let's plug it in that one. It's got the smallest numbers. So 3x plus 7 times 1 equals 19. 7 times 1 is what? 7. And so how do we get rid of that 7?
Subtract it.
Subtract 7 from both sides. So 3x equals 12. Divide by 3. And end up with x equals 4. Make sense? Any questions? Okay. What else?
22.
Any others before we do the proof?
Number 12.
Number 12. And actually, before we do that proof, we ought to get the answers to the other lesson just so we don't like run out of time. And then we can come back and hit 22.
The next lesson is like all proofs.
Oh yeah, that's true. But they're easy. Number 12. What is your question about number 12? show that polygons are congruent by identifying all congruent corresponding parts. Then write a congruent statement. So what angle is congruent to angle A?
Angle F.
Great. So you would write that. And then what angle is congruent to angle J?
Angle B.
Yeah, good. And then you would write that. And you would write all of those. And then you would say that the polygon is congruent to the other polygon. Make sense?
Yes.
Good. Any other questions before we do any proofs?
On 12, are they technically congruent because one's the mirror of the other?
Congruent. So congruent, that's a good question, actually. So congruent doesn't have anything to do with orientation, only size and shape. Not so you can have two congruent things that are reflected or whatever. So only size and shape, not orientation. It's a great question. What other questions before we tackle any proofs?
Well, I have a question, but it's a proof.
Okay. All right. Are there any on 4-4 that are not proofs? And we'll get those answers before we do anything else. What numbers did we do on 4-4? 6 through 22. So 8 and 10 are the type of problems that should not have been assigned. And you should be like, okay, did you assign these? No. And then I'd say no, and then we all move on with our life, and they're omitted.
Question marks on those two.
Well, good, because we're not going to do them. What you'd have to do is a whole bunch of nonsense with, like, you'd have to do a bunch of distance formula stuff and a bunch of other stuff. We do not do coordinate proofs in this class.
Oh, and 16 and 18.
What?
Not proofs, 16 and 18.
16 is side, 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 and 18 is not possible.
What about 14 and 22? Because it says flow proof. And what's a flow proof?
Okay, so I've said that before, and I'll say it again for the third or fourth time at this point. If it says flow proof or paragraph proof, write a 2-column proof. We only do one kind of proof in this class.
22 was like, it gave you the answer in the cube.
No, it didn't.
It said
Yeah, well, it was just reflective and,
R
or reflexive and then
S
side, side,
Yeah, so it's like a few steps. That's not the same as giving you the answer. I told y'all these proofs are not hard. They're not a huge amount of steps. Let's see, they did 22 in how many steps? Let's see. Probably. That's entirely possible. There are 3-step proofs in this unit. They definitely exist. Let's see if that one is one of them. What is this? 4-4, number 22. 4-4, number 22. Where is it? What's happening? Extended 4-4. Lesson 4-5. Lesson, I'm confused. What's happening? What am I looking at? Lesson 4-4. There it is. 22. Oh, they have flow proof. So symmetric property. CPCTC, so you're probably missing one step. Side angle side.
Yeah, have it.
You have symmetric property.
Yeah, and side angles.
You have reflexive. Okay, you did symmetric. You did reflexive property. Which one? Let's see. We're trying to prove TQR is congruent to SRQ. So those top ones, and we're given that the big triangle, probably TPQ, and SPR. And so you did QR is congruent to RQ, reflexive property. Is that what you did? Okay. You don't know from that by itself that QT is congruent to RS. You would have to say that QT is congruent to RS because of CPCTC, and then you would say side angle side. Yeah.
Question on 14.
So almost. On 14 on 4-4.
Yes.
Okay.
It says L is the midpoint of J and then KM. Does that? I was confused because it's like a bisector. Is it all? Which that means it's also the midpoint.
So bisector is like you'd have a segment that bisects. Midpoint means that this point is in the middle. They tell us ultimately, they're going to tell us the same thing. Either one is going to be able to say this is congruent to that because of definition of midpoint or definition of bisect. So they ultimately give us the same information, but one's a point and one's a segment or whatever.
Yeah, it's just they cross each other in the midpoint.
Right. Yeah, so they are bisectors, but it's saying specifically that L is the midpoint, which tells us the same amount of information. All right, let's go back to 4.3 and look at, I may put it up on the board because there's a lot of hoopla to look at. It's going to be easier than trying to draw all the hoopla. My fuzzy fell. Where's my cell phone? There it is. All right, number 22, page 260. Hello. Gina, submitted late.
I submitted late.
See, I was gonna stay with you last night.
It's going to be fine.
I just did it this morning.
Well, there you go. Sometimes that's a thing that needs to happen. No problemo. No, not shame. Smack!
Okay.
No. Lots of joy.
Don't worry, Helen, I feel adequately shamed.
I think she was talking about me at that point.
Push you one direction.
That's interesting. I didn't know you could do that. I wonder if that's a better way of doing what I normally do. We'll find
If
out.
I make another one direction joke, you're gonna kill me.
I mean,
Yeah.
I might kill you
Just
regardless,
like,
Oh.
Don't take
I'm going to
it
push you off a railing. Okay.
Now you just made a one direction.
I know. At your expense, so it was glorious. Okay. All right. Number 22. So, put the statements used to prove the theorems. If you read instructions, that helps. Provide the reasons for each statement. So, what is the justification for this first step right here? Yeah, I agree.
The triangle.
The answer is C, Mark.
CPCTC, congruent parts of congruent triangles are congruent because it tells us that these triangles, that RST is congruent to XYZ, right? Right. So it tells us that, and since they are congruent, their corresponding parts are congruent. So CPCTC, corresponding parts of congruent triangles are congruent, right? That's this line. Now what about these one? So just like to parse what's happening, all they did from here to here is they took and flipped these around. So what property says that we can take it and flip it around? It's not reflexive. No, it's not substitution either. Symmetric property. So this is a symmetric property. Symmetric property says that if A equals B, or in this case A is congruent to B, then B is congruent to A. We can take it and flip it. No, it's not reflexive.
Why not?
Reflexive says A equals A.
So it's the commutative law?
What?
It's the commutative law?
No, it's symmetric.
No, I'm saying it's the same thing. If this equals this.
No, so commutative says that A plus B equals B plus A.
Which one says A equals B, B equals A?
Symmetric.
Oh, I thought it was reflexive from the.
Okay. Now, what is this? This is why I hate flow proofs. Flow proofs are so dumb because you just like shove it in all kinds of random order. This is in fact a given. That is true. Flow proofs are stupid. Anyway, continuing on what we're doing. Oh look, they want you to turn this into a 2-column proof. So you'd put this at the beginning, and then you'd put this, and then you'd put this, and then you'd put that, and what would you say?
You didn't do it.
Symmetric.
So, no, not going through this proof logic. So in this proof logic, we would say this is true because, and I would write some abbreviated version of the theorem that says if all the corresponding parts are congruent, then the triangles are congruent. That's what I would put. What? No, we're proving what you like. We're proving the one step to get there. We're proving that you can say without all of this other junk, you can just say that this is true because symmetric we're proving the congruence of triangles is symmetric.
So what property are we?
That's freaking read. I just said that We are proving that the congruent. I can't even talk. Just, if you use your ears and brain, you got this. We are proving the congruence of triangles is symmetric. That's what we're proving. So we can't just use it, right? If we're proving that theorem, we can't use that theorem. That's circular reasoning. That's a bad idea. That's saying the sky is blue because the sky is blue. That doesn't work. The sky is blue because of wavelengths and particles and all these other things. Right? Makes sense? So, as I was saying, this last one, the justification is that if all the corresponding parts of a polygon are congruent, then the polygons are congruent. So that we can say that.
Okay, so that's why.
It's not a waste of your time. Because you're not understanding the things that I've been telling you since the beginning of the dadgum class. Since the beginning of the dadgum class is you learn to use logical reasoning. That's the whole point. Of course, who cares why triangles are congruent? It's been proved literally millennia ago. This is Euclid. If you're not being expected to do a proof that's going to rock the math world. Because if you were, then you would fail. Because you don't know enough yet.
You are very brave today.
I think that's true. Okay. So in rage, I'm like spitting. Watch out. Okay. What other proofs do we need to look at?
If you were by
24 on this same lesson? Okay. That's easy, bro. Well, then why are we looking at it?
Oh, I thought you, because the answer.
Oh, you want? Okay, I'll put it up on the screen. Is that what you want? Okay, great. Is that? Nope, doesn't matter. I don't know why that button is in two places. The answer is because.
So many notifications.
The answer is because Android. All right.
Why don't you turn them off like you're supposed to?
That doesn't make any sense,
Why
Greg.
would he be supposed to in his own class?
There is 24.
I didn't mean now.
Oh, there's so many.
There's so many. Yeah, because as of this lesson, now this is the only lesson where this is true, because as soon as we get to 4.4 and then 4.5, we get some way shorter ways to prove the triangles are congruent, right? But as of this lesson, as of 4.3, the only way you can prove two triangles are congruent is to say that every last bit of it's congruent. You have to say that this angle and this angle and this angle and this angle and this segment and this segment and this segment. You have to say they're all congruent. And when you can say all of that, then you can say they're congruent. But that's only for this lesson, only for this one lesson. Right? Not after this lesson. After this lesson, you have side, side, side. You have side, angle, side. And then in the next lesson, you're going to get angle, side, angle. And angle, angle, side. And so you're going to have all these other ways to prove that triangles are congruent. And if it's a right triangle, you can even go shorter. You can do hypotenuse leg or leg, leg. And go even smaller, right? But as of this, that's why there's like 100 things in here. And by 100, I mean 7, right? But that's why there's all these things in here, is because as of this lesson, all we knew, the only theorem we had to work with was this is congruent to this if it's all congruent everywhere, right? And so you have to be able to say that the segments are congruent. You have to be able to say the angles are congruent because of the vertical angles. And the only one that I would argue is even remotely tricky to get to is that PRQ is congruent to TRS because vertical angles, and it's not that tricky, right? Other than that, it's pretty straightforward.
Wait, so why would we have to use vertical angles? Can't we just use like the third angle theorem? That if
Continue.
the
What are you
two
saying?
angles are equal, so that means the third angles, because they all have to add up to 180.
Did we have this in fourth? Did we have that theorem in 4.3?
Yeah.
Pretty sure.
The third side thing, I think that was.
Oh yeah, we did.
Yeah.
Yeah, we did.
Just use the transitive property to say because P and R are congruent and R and T are congruent, and Q and R is congruent to P and R, and R and S is congruent to R and T, that Q and R and S are congruent because all four are.
So transitive property is only this to this equals this to this. So you'd have to do that in a couple steps to get there, to do that. Yeah, so you could, so the PRQ and the TRS, you could say by the third angle theorem or by vertical angles. Either way, they're congruent, right? Same single step deal there. Yeah, and then other than that, you got to get, so you're given a bunch of segments that are not written on here. Let's see, RT and RS. RT and yeah, so you're given a whole bunch of stuff.
Because if they were to write it all out, then that would say that PR is congruent to QR is congruent to RS is congruent to RT.
No, it would not. That's what I keep telling you. That's the one mistake you keep making. You can't, if a theorem says if this is congruent to this and this is congruent to that, then those are congruent. You can't do that to get this long old stretch of things. You got to break that up into the chunks, right? You can't just, because that's not what the theorem says. The theorem just says this and this. It doesn't say this, right? Does that make sense?
Yeah.
Okay. Yeah. But luckily for us, when we get to 4.4, we do get some like 3-step proofs, and they're nice and they're easy. All right, so do we need to look at some of the proofs from 4.4? Number 14, you just did it, so you want to see if you did it right. Is that what I'm hearing from you? Okay. It was 5-7. What'd you say?
5 steps in.
Oh, 5 steps the way you did it? Okay. It's going to be funny if it's much easier. It was 5 sandwiches. All right, I need some water before we do that. And maybe some almonds.
And some chill pills.
Some what? Some chill pills? Always. Always need chill. You too. Do school. Quit futzing. All right, 14, page, number, crowded. Yep, that sounds right. I don't know. I said page number and you said crowded. So, you know. All right, write a proof for this parallelogram. Probably. Actually, we don't know that it's a parallelogram, but that's something we're going to be able to prove later. Okay, so we got this rhombus-looking shape. Yeah, you know what the plural of rhombus is? Nope, it's a good guess, but no. No. Rhombi is correct. No. This is like the same as that other one, but like it's easier because we have new theorems to work with now. So we are given noise is what we are given. Let's do your homework for Grace class. Yes, I did assign homework, actually. Did you do your homework?
Oh, it was, no.
What is it?
To watch episode 4.
I've already.
Why not? What a loser you are. Okay.
I mean, I've already.
We are given
Technically.
Star Wars.
Episode 4, there's
a cultured
Right,
swine.
like Roger said.
He's just saying, watch this one movie.
Even
and
I
see
know
what
that, and
you
I'm like.
I would argue the first movie, but you know.
Oh.
I mean, it's
see. Not
first
chronologically,
movie, like,
but the order they were made.
I mean,
If you've never watched Star Wars before, I recommend the Machete order. I think it's the best way to introduce a newbie to Star Wars. Hmm? It's terrifying.
It looks really good, but
I
like,
can't,
it's
I just see
terrifying.
like, oh, it is a bug. I was
It's
right.
Helen.
That was terrible, Jacob. I bet Helen thought it was funny, but
I'm gonna like One Direction you off a cliff.
girl, you got to work on your like phrasing.
Yeah, yeah.
That wasn't too much. It was just not funny. You got to work on it.
It wasn't supposed to be funny, it was supposed to be a threat.
It was supposed to be funny. That's why you were laughing when you said it.
Threats need to sound more serious.
Yeah, if you're actually trying to threaten, you need to work on that too. Don't laugh while you're giving threats. That's not going to work.
Unless you can pull off like the Joker.
Yeah, right. The maniacal.
Right?
Mm-hmm.
But maybe not yet. Maybe someday. Not right.
I can do a pretty good evil now.
Do not demonstrate.
I'm not sure if I believe that.
No, I'm not gonna demonstrate it, but
Dude.
All right. There's the beginning. What should we do?
We should say that
The
JL is
midpoint.
congruent to L and
We should say what now?
JL is congruent to L and through definition of midpoint, and ML is congruent to LK through definition.
Sounds great. I've talked about this a lot. Let me swallow these almonds. I'm not talking through a mouthful of almonds. If you're looking at a proof and you're like, where the heck do I start? Right? Which is likely to be a common predicament. My recommendation is look at the given and see, does the given tell me anything? What does midpoint tell me? Midpoint tells me that the two sides are congruent, right? So that's a great place to start. So let's start there. So ML, segment ML, is congruent to segment LK. And JL is congruent to segment LN because definition of midpoint, right? So this is congruent to this is congruent to this. So it might also be useful to kind of keep in mind where we're trying to go, right? So you might want to label, if you're not like sketching the pictures in your work as you're doing these proofs, I recommend doing that because then you can scribble on them. It makes your life a lot easier to see what you're doing. So MJL, so this one, and KNL, so this one. So we're trying to prove that those are congruent. So you want to get stuff with those triangles involved.
Do it because SSS.
Yeah, so we can say which triangles are congruent because of SSS. JLM and you would want to say NLK because the order matters.
It does?
Yes.
I asked.
But it says,
Because corresponding parts have to be connected to corresponding parts.
but it says proof MJ. Does it matter?
That's angle, yeah.
Oh.
So triangle, it doesn't matter, like I could do MJL, But if I do MJL, then I need to do KNL for the other one, right? So triangle, let's do one more. L, K, J, M is congruent to triangle L, N, K. And you were correct. You can do that by side, side, side congruence. Absolutely.
And then you can do the angle. MJL is because of congruent triangles or whatever it's called.
CPCTC.
CP or CP?
CPCTC. Congruent parts of congruent triangles are congruent. CPCTC. Great. Easy money. Any questions on that problem or any other ones from this lesson?
Who's it? 22.
Which one?
22.
Yeah. Same page.
I really like 20.
You like 20? Isn't that one where you just like write the answer? Oh no, just kidding. 20 is the 20 has answers, right? Triangular pyramid. And part B is in the appendix, so we can look at it if we need to. Okay. But we're looking at 22. 22, we got this trapezoid looking thing. We don't know it's a trapezoid. It might be a trapezoid, probably is a trapezoid. We don't know it's a trapezoid. Later on, we can learn how to prove it's a trapezoid, but we don't know. We don't even care. We don't even know any theorems about trapezoids. Q, R, P, TS. And we are given triangles and angles are congruent. Given triangle TPQ is congruent to triangle SPR and angle TQR is congruent to angle SRQ.
Since the angles are congruent, could the triangles be congruent? Or is it only the triangles?
Well, that's eventually going to be true, probably, but. So, and we are trying to prove what? Let's see.
The bigger triangles.
Nice. Triangle TQR is congruent to triangle SRQ. So, we are told that TPQ is congruent to triangle SPR. So we know those are congruent. We also know what's already labeled up there. Angle TQR is congruent to angle SRQ. So we know that. And we're trying to prove that TQR, so this triangle is congruent to that triangle, right? So, what might we say?
TQ is congruent to RS through CPCTC.
Yes, we can. You're like, I know the one I didn't get. I've got it now. That's true. We can say QT is congruent to RS because CPCTC. So we just said this is congruent to this, right? Now what can we say?
QR is congruent to RQ through the reflexive.
True enough. QR is congruent to RQ because of the reflexive. I don't know why I put a dot there. I wrote it all out. Property. We said, psh. Now what? Somebody's not Reese. Now what?
You say that QR is congruent to TS?
QR is congruent to TS. QR is not congruent to TS. I don't understand what you mean.
I only have
Oh.
3 steps. Wait.
So,
Wait, we can do it because the SAS.
Yeah, we can do it because of side angle side now. Triangle TQR is congruent to triangle SRQ because of side angle side. Because side angle side. Make sense? Any questions on this problem? Any other questions from this lesson? All right, goodbye. We'll see you Thursday.